we can go into the free response ones if you're that far into it too. It's up to you.
We do know the 10.
Yeah, that's a good one. You know, the no calculator section, especially the multiple choice, and I've said this many times, but that's the section that really gets at, you know, some of your algebra, some of your trig, some of your, you know, pre-calc stuff, graphing, just little things you have to do, be able to do without relying on the calculator. And not quite as much in the free response. But, you know, your derivative rules come through a lot more. The free response are really trying to get at your calculus knowledge more so. I mean, multiple choice also, your calculus knowledge, but that's where they also test some of that prerequisite knowledge you have too. So the free response ones tend to work out pretty nice if it's a no calculator one and don't have a lot of algebra. Now, there could be, you know, a few points where that's important, but. All right, so let R be the region of the fourth quadrant closed by the x-axis and the curve y equals x squared minus 2kx, where k is greater than 0. The area of the region is 36, and the value of k is. Okay, so you really need what? I mean, what really do you need here to be able to set this up? A picture, I think. I mean, I think you need a picture, right? I mean, if you had a picture, let's put it that way, it'd be a lot easier to do, right? So what does that look like? What kind of graphs are going to be? It's going to be a parabola, right? So if we start thinking about what we know about a parabola, okay, we want the part in the fourth quadrant, okay? So what are some things you can do to graph this? Any ideas? Okay, that would be one option. How do you find the vertex? Okay, fair enough. Now, actually, this can be a good thing to do sometimes. Is in a general quadratic like this, the vertex is, the x-coordinate of the vertex is at negative b over 2a. That's something you maybe learned way back in Algebra 1. Well, a lot of you guys took it in 8th grade. I don't know what I think they did that. You know, but then you may not use it again. That is where the vertex would be. Well, what's negative b in this case? 2k over 2a would be 2. So the vertex would be at k. All right. Well, what good does that do? Well, they tell you k is positive. So let's say this is k right here. Okay. Now, what could you do with that information? Why do you know it's got to go through 2k and 0? Right, it's equal on both sides, but why couldn't it be 1.5k and half k that it goes through? I mean, I agree. If this is the vertex and it's going to open up, it's got to be, the vertex has to be in the middle. But how do you know it's 0 and 2k? That's what I'm saying. I think you do know that.
Because you know that it goes through 0, 0.
Yeah, I know, and I think that's something you could have done to start with too, right? So I think you know that. Now the other thing you could do is get the y value of this. You could actually get the vertex, right? You could plug a k into here. Now I'm not sure how much that helps you, but we do know this is going to open up, so we know the vertex got to be down here somewhere, right? So we can do all that. But I think if we go back to the beginning, we wouldn't have had to do this, right? It's okay to do it. We wouldn't have had to do it. We could have done this. We could have said, okay, since I know this parabola opens up, and I know that there's some area down in the fourth quadrant, it's got to come up and cross the x-axis somewhere. So another strategy, instead of finding a vertex, could have been, let's find the x-intercepts, right? And the x-intercepts are where this equals 0, right? Well, how do you solve something set equal to 0 like this? Well, one way to do is factor. Factor out an x. Right? So that means x equals 0 or x equals 2k. And that's where, Jace, you would get that. Now, maybe you just guessed it and then got lucky too. I mean, that could happen. But so it's going to cross at 0 and it's cross at 2k. And actually, once we know that, then we know the vertex is at k, right? We know the vertex has to be halfway in between. So now we know that this is a parabola going like this. Okay? And so now this is the area we're trying to find. Okay? Well, so that's part of the battle. That's part of the battle right there, is figuring out that that is what we're trying to find. All right, now what's the integral we set up? 0 to 2k. No. 0 minus. Now what's going to happen is, if you did just put x squared minus 2k in here, that's going to be negative. That's going to be a negative area, because normally that would be a negative area, right? But it says the area enclosed by the x-axis in this curve, and that's when we do our top minus bottom. So it's really 0 minus this, which is going to be negative x squared plus 2kx. Well, it's multiple choice, so I'm not even going to look at your work, right? So I'm not even going to look at your work. But if you did set it equal to that, and then you set it equal to negative, negative 36 is not a problem. Because that's not a problem. Okay? It's kind of like taking the negative out here and dividing it over, no problem. Okay, so that equals 36, and now you're ready to roll. Right? Now the calculus part comes in. So really we have, well, other than setting this up. So now your antiderivative, so negative 1/3 x cubed. Raise that up to 2, divide by 2, so you get kx squared. 0 to 2k, and that's got to equal 36. So now you put your 2k in there, 2k cubed would be 8k cubed, so it would be negative 8/3 k cubed. And then put 2k into here, squared is 4k squared times k, that'd be 4k cubed. And then minus, and then you put a 0 in there, that's all 0 equals 36. So what would this be? Negative 8/3, this would be 12/3, right? 12/3, so negative 8/3 and 12/3 would be 4/3 k cubed equals 36. So divide by 4 times by 3, get k cubed equals 27. K equals 3, right? So there's your kid. But yes, I think getting the graph, without getting the graph, at least that helps you know that the integral goes from 0 to 2k. All right, that's a good one. All right, what else? Which one? 13. 14. Let f be a continuous and differentiable function. The table below gives the value of f of x and f prime of x, the derivative of f at several values. G of x equals 1 over f of x. What is the value of g prime of 2? Okay, so I've said this many times in here. Before you can find g prime of 2, you need g prime of x. So if g of x, now I usually don't like to do a quotient rule on this. I would probably prefer to make this f of x to the negative 1 like that. Okay. If you do a quotient rule, you just got to remember that when you do the derivative in the top, which that'd be worth reviewing, derivative of top would be 0, bottom left alone, minus top left alone, derivative of the bottom, all over the bottom square. That would be how you would do the quotient rule on 1 over x. Now, if you wrote it this way, g prime of x would be negative 1 brought down, f of x to the negative 2 times derivative of the inside would be f prime of x. Now, when you look at all that, that's negative 1 f prime of x, and then the negative power drops to the bottom. If negative powers freak you out, then that's probably not a good way to write it. And if you look at this bottom one, that's going to be the same thing. So quotient rule's okay, and that one you look at and say, that quotient rule actually is a little better. Problem is, people forget derivative of the 1 is 0. They forget that. Somehow it seems like people mess that up. But anyway, we can do it this way and get that. All right, so that's g prime of x, so therefore g prime of 2, we would just put a 2 there and a 2 there. So f prime of 2 would be -4, so that'd be -1 times -4. And then this would be f of 2 squared. F of 2 is -8. So 4 over 64 would be 1/4. That's not right. No, that's not 1/4. That's 1/16. That was all good until I tried to reduce a fraction. Pretty good at calculus. Can't do fraction. Okay, 1/16. Okay. What else? Oh, look at 15. What's a circumscribed rectangle? Outside. Inscribed is inside. Inscribed is inside. Now, so that means it could be a combination of rights and lefts. It might be a right, it might be a left, could be a midpoint. I mean, it could be a lot of things where depending on the region. But again, this is one of those pre-calculus things. We're actually doing this in honors advanced math right now. We're doing log. We're going to do log graphs today. Well, that's what you need to know, right? You need to know that the log graph looks like this. And so from 1 to 7, what are circumscribed rectangles going to be? They're all going to be rights. So you're going to be at 3, you're going to be at 5, and you're going to be at 7. And so it's going to be ln of 3, ln of 5, ln of 7, and then times, each one of those will be times the width of 2. Right? Circumscribed is always over estimate. Inscribed is going to be totally, the rectangle's totally inside. Okay, so we don't do those that often, but they do show up here. So. Now, and then, so what would inscribes have been? Inscribes would have been, if it would have said inscribed rectangles, it would have been ln what? 1, ln 3, ln. Here's another one that's interesting. And then look at that answer right there. ln1 is 0, right? I mean, so sometimes you run into that. ln1 is just 0, so you work it all out to get that. Well, ln1 is 0, so they would leave that off. But if it was inscribed, that'd be your answer. Okay? All right? What else? What else? What else? I'll give you a chance. If you don't have anything, I mean, I'll give you a chance on Friday. Friday would be a good day. I mean, you got a lot of work time today, a lot of work time on Thursday to try to be getting these kind of finished up. And we'll take some time to. How about this one right here? Let's finish with this one. If nobody else has any others, if you got some others, we'll do it. 25. Maybe you're not there yet. If at each point x, y in a certain curve, the slope of the curve is 2y over x, then the curve is. Any thoughts on how to set this up? Separation of variables. You would write this, the slope of the curve is 2y over x. So that's y prime equals 2y over x, which means dy over dx is 2y over x, which means we separate variables. We divide. I would leave the 2 there probably. So we get 1 over y dy, and then multiply the dx over there. So you'd have 2 over x dx, I believe. I think that's what that would look like, right? Do the integral both sides. So this is ln y equals 2 ln x plus c, like that. And then what do we do? E raised to all of this, so e raised to the 2 ln x plus c equals y. You have enough information to answer it yet? I would put this 2 inside of there. This would be y equals e raised to the ln x squared plus c. What about that plus c? What did we do when we got to this part of these? Separated it into and made it a times, right? So it would be this times e to the c, which is just like another c or an a, e to the ln x squared. What's e to the ln x squared? So this is y equals a times x squared. What's the answer? The solution to that curve, or the solution to that differential equation. Right, so it's, it doesn't feel like a differential equation problem necessarily, or a separation of variables, but that's what it is. Okay. Anything else? 17. One more. Now those are not absolute value bars, those are just square brackets. Okay. So if f of x equals 15 minus g of x from negative 2 to 2, then what is this equal to? Well, we can separate this out. Okay. So we can separate this into negative 2 to 2 f of x dx minus negative 2 to 2 g of x dx. Now what do you, now here's where doing multiple choice, you look at your answer choices and you see what they look like. And you see what they look like and you're like, oh, they have g of x integrals into them. So what do I want to do? Well, I'll probably just leave that alone. But what about this? Substitute that. So now in place of that, I'm going to put 15 minus g of x and then do what with that? Do what with this integral? Separate that. So I got negative 2 to 2, 15 minus negative 2 to 2 g of x minus negative 2 to 2 g of x dx. And what is that right there?
60.
That's 60, right? Horizontal line at 15, negative 2 to 2, 4 by 15 rectangle, which is 60. And so 60 minus 2 integral negative 2 to 2 g of x dx. So this one. Okay, so just properties of integrals, splitting it apart, doing stuff like that. Okay, all right. Well, let's again, if you need some help on any of those, I got some questions, let me know. But really, big push here. The rest of this week, sample 4, sample 5. I've got, matter of fact, let me pass. Well, you need another packet. Unless you're all done with all those. If anybody is. Okay. But these would be the calculator multiple choice, the rest of sample 5, the rest of sample 5 is multiple choice. I'll let the sub pass those out. Unless you're going to be, or Thursday. If you're going to be gone on Thursday, you should grab it. Okay, if you're going to be gone on Thursday, you should grab it. Okay.
Yeah.
I mean, I don't know when you get it. I don't know where they even tell 9:30 or 10. I'm guessing you'll be a part of the time for sure. I mean, but, if you're unsure and want to take one, you certainly can. Okay, but, all right, Friday we'll go over some questions of those. We may start on some free response kinds of questions a little bit, But like to kind of get sample 4 and the sample 5 pretty much done by Monday. We're not gonna hand them in yet, but pretty much have those down.